Hello everyone, I am Dr. Jyoti Mandala. Welcome you all to the video lecture series on the course Operating Systems. So in this lecture, let us understand about what is CPU scheduling. Up to our last lecture, we learned about the basics of this process management, where we learned about what is process, what are the different states the process has to go through, and we also understood like what are the different queues the CPU, like in case of switching from the running state to ready state and from ready state to the waiting state, what all the different kinds of queues has to be maintained. We understood like ready queue, job queue, IO queue will be utilized, and also we learned about how a process can be created and terminated. I hope you all are clear with those concepts, right? So in today's class, let us understand introduction to this CPU scheduling. So we will be understanding what actually the use of this CPU scheduling, and we will be analyzing different CPU scheduling algorithms also. For analyzing that one, what kind of scheduling criteria we are going to use, that also we are going to understand today, right? So let us start with the video. So what is the use of this CPU scheduling? Normally, we already understood in our lecture in the earlier videos, where all the process which they want to be executed by the CPU, they will be moved from the secondary memory to the main memory, right? So in the main memory, they will be maintained in the form of a queue, which is called as a ready queue, right? Now in the ready queue, we will be having more than one process. Okay, now which process has to be selected from that ready queue, and that process has to be given to the CPU, because CPU at one particular time it can execute only one program or one process, right? In that case, of all the available process in the ready queue, this CPU scheduling is one kind of software that helps us in choosing one process from that ready queue, and that can be transferred to the CPU. Okay, so that is the main use of that one. So let us just highlight those points here. So CPU scheduling algorithm, what it does, it helps us. I'll just mention the points here. You can make a note of that one. So this scheduling, this decides the order in which the processes are to be executed, because we have more than one process available in the ready queue. If you are not clear with this point, I'll just quickly revise what we learned in case of process states. Do you remember these states? We used to have the ready queue, ready state, and then we also learned like this is the new state, and then we had a ready state, and then we had this one is called as a running state, which is called as a CPU, which will be taken care by the CPU, and here we'll have the waiting state, and finally we have a terminate state. I hope you all can recollect these things. So how we used to have this one. So this one is called as a new state, okay, and this is called as a new state, where from when a process will be moved to the ready queue, and then we have a running state. This is what we learned in case of process state diagram concept, and then this is called as a waiting or a blocked state, and then we have this is called as exit or terminate state. Right, now we have multiple process available here. We are maintaining all the process in the form of ready queue. This is our main memory. Okay, this is our main memory. Now in this main memory, we have multiple programs available here which are waiting to be executed, which are waiting for their turn to get the CPU. Now let us consider we have process P1, P2, P3, like that. Now one among these processes should be brought from this state to the ready state. Who does that? The CPU scheduler will be doing that. I think you all can recollect, we have a term called short-term scheduler. Short-term scheduler is this one, who will transfer the process from the ready state to the running state. That is what the use of this CPU scheduler. that is what written here. This will decide the order, because we have multiple processes available here, which process has to execute first. To decide that order also, it is not the case always the first process which is available here that has to be executed. That is not the case. There is a different algorithms available. There are different kinds of CPU scheduling algorithms available. Each algorithm will choose a different process. So that is why it is told here, this decides the order in which the processes has to be executed. So the main idea behind the CPU scheduling is, one among these processes, what are all the available here, that will be sent to the running state and that will be executed by the CPU. That is what we have the use of the CPU scheduling algorithm. Now when we need the CPU scheduling algorithm, why we need to achieve this one? Because we want to achieve the multi-programming efficiently. So the main advantage of this one is to achieve the multi-programming. Just make a note of that one, all of you. To achieve, why? Because we are in the multi-programming environment to utilize the CPU efficiently, because we don't want to have the CPU idle time, right? And we as much as possible we want to reduce the CPU idle time. So in the multi-programming environment, for effective CPU time utilization. Okay, right? Now this is called as a CPU scheduler, right? You always, what is short term scheduler? This is the short term scheduler. So we already understood that one, right? So this short term scheduler is called as a CPU scheduler, which is one kind of software. Don't get confused. This is one kind of software where that will help us in choosing one process from this ready queue, and that will be sent to the running state. Right. Now what are all the different situations we have? We have different situations here. What kind of situations? When the CPU scheduling is used, CPU scheduler or whatever the scheduling algorithm we are going to learn in future, that works in the following situations. What are all the situations? Note down the situations, all of you. So CPU scheduler is used in the following situations. What are all the situations when the CPU schedulers are used? First case is when the process switches from the, obviously the first case, when the process switches from the running state to waiting state, or we can say first one will write running state to the ready state. That is what we understood here in this diagram. Can you see? Whenever we want to switch from the running state from the ready state to the running state, or from the running state to the ready state. Okay, next one. Second scenario is when the process switches from the running state to waiting state. Okay, so whenever it requires any IO wait, like that, any event to be occurred, in that case also the CPU scheduler will help us in moving that one from the running state to the waiting state. Or else the scenario the situation may be like, if you want the process to be switching from waiting state to ready state. Or else the fourth situation is when you want to terminate the process. Okay, so these are all the four situations that help in which or where we want the CPU scheduler can be used, right? So considering these 4 points or these 4 situations, the CPU scheduling algorithms are classified into or categorized into mainly 2 types. So note down those 2 types, all of you. 2 types of CPU scheduling algorithms. So types of scheduling. We have two types of scheduling. First category is called as a preemptive scheduling, and the second category is called as a non-preemptive scheduling. First one is preemptive. Preemptive scheduling, and the second category is non-preemptive scheduling. Right, now what is the difference between these two categories? Preemptive scheduling is nothing but, suppose whenever whenever a process has been selected. I'll repeat once again this same concept, and let us erase this one. Now let us consider a scenario where from the ready state or from the ready queue, we have multiple process available here. Okay, so let us consider we have process P1, P2, P3, P4. This is one queue. Let us consider we have process P1, P2, P3, P4, P5, P6 process are available. Now this is our running state, which is our CPU. Now one among these process will be selected. That may be depending which process has to be selected, that depends upon the type of the algorithm. Now if you are using preemptive scheduling algorithm, then in that also different types of algorithms are there. Now whatever algorithm you may be using, one process will be selected. Let us consider we have selected this process P4. Now this P4 will be moved to the CPU. Now CPU will be executing this one. Now in preemptive scheduling algorithm, what happens? Once a process has been selected and it has been sent to the CPU, until and unless its execution is done, it cannot be, the CPU cannot be switched to another process. I hope you all are understanding. Suppose this process requires 10 minutes of time, okay, to finish its execution. Then for that 10 minutes of time, until and unless 10 minutes of time the CPU has been utilized by this process so that its work can be done, then only the CPU will move to the any other process of the remaining process. That is called non-preemptive. Non-preemptive is nothing but until and unless the process has been executed completely. That means, in the other words, the CPU cannot be forcefully taken by the other process. That is what the the meaning of non-preemptive. Preemptive is nothing but if this requires 10 minutes of time, even though depending upon the type of scheduling algorithm, if it has been executed for 2 minutes only, then depending upon the scheduling algorithm, there may be a chance like the CPU can stop executing this process and another process can be selected and that can be assigned to the CPU. Right, so that means forcibly a CPU can be transferred from one process to the another process even though the previous process execution is not completed. I hope you all are understanding. Okay, non-preemptive is nothing but not releasing the CPU until and unless your task is done. Preemptive is nothing but forcibly you have an option of switching the CPU from one process to the other process. Right, just make a note of that point, all of you. So preemptive is nothing but forcible switching depending upon the scheduling algorithm. How it will work, we will be learning in future. Right, now under that with different types of algorithms are there that we will see now later. Now in non-preemptive is nothing but cannot be stopped. So once a process has been allotted to the CPU, it has to finish its execution. That is what the non-preemptive scheduling algorithm is. Right, now under the preemptive scheduling algorithm, in our lecture series we will be learning about 3 types of scheduling algorithms. So just to make a note of those 3 scheduling algorithms. In future classes we are going to learn in detail about all these kinds of scheduling algorithms. So the different kinds of scheduling algorithms we are going to learn under preemptive is we will be learning about round robin algorithm, don't worry, all these algorithms we are going to learn. SRTF algorithm, shortest remaining time first, that is the full form of that one, priority. So these are the algorithms we are going to learn under preemptive scheduling algorithms. And then under non-preemptive algorithm we are going to learn about FCFS, which means first come first serve algorithm, SJF, shortest job first, and also priority of non-preemptive priority, that is also we are going to learn. So in total of 1 2 3 4 5 6 algorithms we are going to learn in our future classes. Right, now if even we have 6 algorithms, now if you are having different types of algorithms, there should be some criteria, evaluation criteria, which helps us in measuring the strength of that algorithm, like which is used to choose which algorithm is best, because we have different types of algorithms. To choose which algorithm is best, we have different kinds of scheduling criteria. So let us understand those criteria first, and then those criteria will be applied for each and every algorithm, and we will be analyzing our algorithm there. Okay, so keep heading all of you. Scheduling criteria. What is the use of the scheduling criteria? Scheduling criteria is used to choose which algorithm is best, because we have, as per our this video lecture series, we will be learning 6 types of algorithms. Okay, all these, among all these 6 types of algorithm, to choose which one is best, then to do that one, we have different kinds of scheduling criteria. Okay, so the first scheduling criteria is, first one is CPU utilization. Now, what is the use of this CPU utilization? This CPU utilization talks about amount of CPU time is being used by the scheduling algorithms. Means some scheduling algorithms, if you take round robin or FCFS, then if this algorithm takes less CPU time, then we will be considering this as the best algorithm by using this criteria. So that this CPU utilization is nothing but this talks about the amount of CPU time has been taken by the algorithm. Okay, so that is what CPU utilization. Just make a note all of you, amount of CPU time used. Right, this is the first criteria. So there is no formula for that one. The time will be generated automatically. It's like the number of maybe in terms of seconds or nanoseconds. So you will be getting the CPU time, and that time is your measuring criteria. We have the other one, which is called as throughput. Throughput is nothing but in a particular amount of time, let us consider like half an hour time or 1 hour time. In that particular amount of time, if you are going to use round robin or if you are going to use FCFS, whatever algorithm may be, how many process has been executed. I hope you all are understanding. That means the number of processes are completed, number of processes have completed their execution per unit time. For a given amount of time, how many number of process has been executed. So if round robin, let us consider like half an hour time you have taken. In half an hour time, round robin executed, 30 process has been completed its execution, and in the FCFS, suppose it might have executed only 10 process execution. Then we will consider round robin as the best as per this scheduling criteria. Right. So throughput is nothing but number of processes completed execution per time unit. Okay, so this is the second criteria. Right, let us now understand the third criteria. Third criteria is waiting time. What is this waiting time? Waiting time is nothing but, see, from this diagram you can understand here, once a process has been moved to the ready queue, that means it is ready to be executed by the CPU. That means it is waiting for the CPU time, it is waiting for its chance. Here they are waiting, right? Now the amount of time a particular process has been waiting in the ready queue to get a chance to be executed by the CPU, that time is called as a waiting time. I'll put it in other words, how much time the process waits in the ready queue. Okay, so that time is called as your waiting time, right? Just make a note, all of you, how much time process waits in ready queue for its execution, or for its chance to get the CPU time, or to complete its execution. Okay, now which algorithm is said to be having the best algorithm if you are considering this waiting time as a criteria is the algorithm that gives less waiting time, then that algorithm is considered as the best one, right? So which algorithm, if always we should have, it should be minimum. Right, now let us consider one small example. Let us consider T0 is the time of the process which it has been submitted into the ready queue. Okay, and let us consider T1 is the time in which it has started the execution. Okay, now what is the waiting time? Now waiting time can be given as waiting time is equal to start time minus arrival time. Understood? T0 is the time at which it has entered into the ready queue. Okay, T1 is the time at which started its execution. What do you mean by started execution? Started execution is nothing but it got a chance to be executed by the CPU. Now that is your start time, and this is your arrival time. So in the other words, you can note down this one as the arrival time, and this one is your start time, right? So the waiting time can be calculated by using this formula. All right, okay, so let us move to the next parameter. Fourth parameter is called as turnaround time. What is this turnaround time? Turnaround time is nothing but once it has been added into the ready queue, and sometimes we may get a chance to be executed by the CPU, and because of this preemptive scheduling algorithm, there may be a chance like it may be going back to like it may be halted for some time, right? And again it may get a chance to be executed. Like that, in that process it may take some time to finish its execution, like 10 minutes of time it requires, but to finish the 10 minutes of time it has taken half an hour time. Okay, so that is called as a turnaround time. Turnaround time is nothing but the time interval between the job submission and its completion, overall completion. Okay, so that is called as a time. Okay, so just note down time interval, time duration between, turnaround time is nothing but time duration between the job submission. That means job submission is nothing but it has been arrived into the ready queue, and its completion. Completion is nothing but, understand, starting execution is different from completing execution, right? So let us consider T0 is the time at which it has been arrived, that is your arrival time. Let us consider one time T2 at which it has been completed its execution. Then turnaround time is nothing but TAT. I will write down it like this. Turnaround time is nothing but completion time minus arrival time, right? So we will be using this formula. Now when we say the algorithm is best algorithm, always it should be minimum. So whenever the algorithm which gives less time to finish its execution, then that algorithm is called as a best algorithm. So the turnaround time should be less and the waiting time also should be less, then only that algorithm is said to be a best algorithm if you are comparing between the algorithms, right? So let us understand the last criteria, which is called as response time. What is this response time? Generally, always, some cases, no, it is not like the final output only we will be bothered about. That is not the case. Like in case of interactive environment or scientific calculations, always we want the first output, like first response from the program or from the process. After we getting the first response, later on it can continue with its new results generation, that is okay, but we are bothered about the first response sometimes, like in an interactive environment and all that. In that case, the time required to generate the first response is called as a response time. Okay, so that first response, whichever algorithm generates in less amount of time, that will be considered as your best algorithm. Okay, so just note down: time required to generate first response. This may not be your final output, but we are bothered here for your first response. Then that algorithm is called as then that time is called as a first response. Always this also should be less. This should be minimum. Right, so these are all the scheduling criteria that we are going to use in our future classes, where we are going to learn about these scheduling algorithms. We are going to learn about all the scheduling algorithms. We are going to learn about round robin, SRTF, priority, FCFS, SJF, and non-preemptive priority algorithm. All these algorithms we are going to analyze with these scheduling criteria. Mainly our focus will be with this waiting time and the turnaround time. Okay, because we are not going to calculate what is the CPU time and how many processes we are going to execute, and also we are not bothered about the first response. Always we want the final output, right? So what we will do, we will be considering the waiting time and turnaround time. So for each algorithm we will understand how each algorithm works, and then we will be going to calculate the waiting time and turnaround time. In the future, from the next lecture onwards, we'll start with the FCFS algorithm, first come first serve algorithm. Okay, so this is about the little bit introduction about the CPU scheduling, what actually the CPU scheduling is, and what are all the different types of scheduling algorithms we have, and what is the scheduling criteria we are considering. I hope today's lecture is clear to you all. Let us all meet in the next lecture. Until then, thank you.